runs another program. Okay. Now, of course, if let's say assume that if he can read readme.txt file, he can probably even write it. Let's say he has also the right permissions on that. So what he could do is he could use that program. So this has a regular contents, right? At the time of using the access function. But before it goes to this line and uses the open function to read the file, he manages to change through another program that is running on a different terminal. He manages to change this to a symbolic link to the password file.
Dr. Mayor,
Yes.
I know you gave an answer to it, but what did you say? Explain symbolic links, because you said it wasn't what he said. What was it?
Symbolic link we did before. You don't remember?
No, I'm just give me a brief.
Okay. Symbolic link means I use shortcuts in Windows. Right. It's same as that in
Okay.
Unix. So symbolic link means if you have say readme.txt file in say folder 1, and if you want to link to it from folder 2, you can create a symbolic link to this file. So if you can access this file from this folder through that symbolic link, and you can update the file. Okay. So what he does is, what the user does through a second program running in the background, in addition to this, is he quickly changes back and forth. He has to do it in a trial and error approach. You cannot do it in one attempt. Why? Because at this point of time, when this program is using the access function to check whether he has a read permission of the file, this has to appear like a regular file. You cannot have symbolic link. Because if it has a symbolic link to the password file, at this instance, at this point, the operating system is not going to let him read the password file, because this checks whether the access permission checks based on what? The real user ID has the read permission on that file. So at this point of time, if his background program is changing back and forth and the readme.txt file is having a symbolic link to a password file, the operating system is not going to let him to read that file. So the access function is going to fail. Alright? So at this point, the readme.txt file has to have the regular contents, no symbolic link, just the regular contents. But before the control of this program goes to the open function and the file is opened, the background process, the other process running in the background of this user has to change the contents of the readme text file to a symbolic link file. Yes.
I have a question, please. So, if the background program can change the contents of the file, so that means there's no file protection, because two programs cannot access a file at the same time.
The file is not yet open. You see, this readme text file is the real user can open the file and write the file.
So you just check the access. It doesn't. It has
Yeah,
to
the access permission just checks whether you have the access. You don't really open the file.
Okay.
Okay. So before you hit the open line, because that's why you see the if block, it could be executed. It could be that after the if block is executed, you could have what is called a context switch, or what is that called? This process is not executed for a while and some other process is executed, right? So in the meantime, the time gap, if he can manage to change this to a symbolic into a password file, by the time the control returns back to this program and the open function is executed, right? Then when the open function is executed, if the file has a symbolic link to the password file, what can happen? Remember, the open function checks based on what? The effect user ID, right? So the effect user ID of this process is the root. So what the operating system will check? Whether the effect user ID can read the file. And the effect user ID is the root, and the root can read the password file. So which means, since it is a set user ID program, the real user, the regular user, can manage to open the password file and read the contents of the password file. Right? So what is the problem? The time gap between this thing, the access function and the open function. So it's also called the race condition. Race condition means we are both running kind of in a race where the time gap should be as minimum as possible. The time gap between what? The two functions. After you use the access function to check whether he has the access permission, because the access function, that's what it does. It checks whether the real user has the read permission on the regular readme.txt file. And the open function believes what the access function checked and tries to open the file. But the open function checks based on the effect user ID, whereas the access function checks based on the real user ID. The access function did its job, but on the background, the user managed to change the contents of the file, the symbolic link file, and by the time the control goes to the open function checks based on the effect user ID, and since the effect user ID of this process is the root, because it's a set user ID process, it happens so that the real user can manage to open the password file as a root and read the contents of the password file. So this is the problem with this code. Okay? So what could be the solution?
Make sure when function 1 get through, they happy where to set up that function 2 can't open up until function 1 is completely closed.
No, as I said, you are not really opening the file up to this point. Here you are just checking the access permissions.
You eliminate the time delay?
You want to, yeah, what is it?
I don't say it's not very much
Yeah.
time.
You want to eliminate the time gap, right? But you eliminate the time gap by doing what is called, you reduce the privilege. Even though this is a set user ID process where the privilege is escalated, right? You do what is called reduction in the privilege by doing something like this. Okay? So let me go through it again step by step. So this is what is called, this is the modified program to correct that vulnerability. Alright. What it says here, the effective user ID is equal to the get effect user ID. Remember, this is a set user ID process, right? So let's say the root, the owner is the root, and the user, the real user running is say some Y, right? So what is going to be the effect user ID of this process?
Root.
Between the root and Y, what is the effect user ID of this process at runtime? If the real user running this is Y,
It's gonna be the owner.
owner, right? Because it's a set UID bit is set. So the effective user ID is the root. Okay. Then there's another line here. The UID is get UID. The get UID function returns the real user ID of the user running the program. So even though it's a set UID bit, the real user running the program is user Y, right? So the UID will be user Y, the regular user. So what you do now? The privileges of this real user has been elevated to that of the effective user, the root, right? So, but you try to reduce the privilege by setting set user ID is equal to what? Set effective user ID is equal to the user ID. By doing this, what you are trying to do? Before this line, the effective user ID of this process is the root,
The owner.
or the owner of the program, right? And the real user ID is the real user running the program. Now you are setting the effective user ID is the real user ID, which means you are reducing the privileges. The effective user ID of this process from this point onwards is what? The
Y.
effective user ID is Y.
Why?
Alright? So now you try to open the program. There is no need to use an access function. Now try to open the file and read the file. The open function checks based on effective user ID, you know that. But the effective user ID is now Y. So if only Y can open and read the file, this will be a success. If Y cannot read the file, it will be a failure. right? Because at this point, the effect user ID is not the root. If it is a root, the root can open and read the file, yes. But at this point, since you are reducing the privilege, the effect user ID is user Y. The user Y, if he cannot open the file, he cannot open the file. Only if the effect user ID can open and read the file, he can read the file. So after you read the file, you are done with what you want to do with the open and read function. You set what? You get back the original privilege, because you know this is a set UID program. You don't want to reduce the privileges forever. So after you really read the file, you set back to what? Set the effect user ID to be
X.
the root, which is this EUID. The root is stored in this variable, right? So you set it back to this. So that's what I do here. Okay? So I drop the privileges or reduce the privileges, and then open and read the file, and then I rise the privilege back or restore the privileges by setting set UI EUID, the effect user ID, to be the root, the effect user ID. So from now on, from this point onwards, this program can be run as a set UID program. And this is some idea how the password program is also written, because you may be able to open the file, but you could update only your record in the password program, right? So programs, the set UID programs should be written very carefully. Okay? Otherwise someone could launch the time of check to time of use attack. Right.
So to reduce the privileges, you would have to eliminate the access function or something?
Not really. You are trying to use only one function and prevent the time, avoid the time gap problem. But you eventually want to open the file, right? And the open function, you know, that goes with the effect user ID. So if you do not drop the privileges and stay with the effect user ID being the root, right? Still you have a problem, because then you open the file as a root, right? So which means you want to make sure, that's why you use the access function to check whether you can open the file as or access the file as a regular user, but that generates a time gap problem, right? So which means the only way you can open the file and read the file with the right permissions is if the open function checks whether the real user ID has the read permission. But since the open function checks based on the effect user ID, the only way you can solve this problem is bring down the privileges, make the effect user ID to be the real user. And since the open function checks based on the effect user ID, but that is now the real user ID, you end up checking what? The real user, whether he has a read permission on the file. And then once you are done with reading the file, you raise the privileges back by setting the effect user ID to be the EUID, which is the root. Okay, so you drop the privileges and then open and read the file and then raise it back. Okay? So go through it a couple of times. I have explained that in the words, the other page 2. And this is quite interesting attack. So it's called the race condition attack or time of check to time of use top-down attack. Okay? Okay, so now on it will be more easier. Attacks on database systems. Okay? You all have taken a database course, at least come across database, right? You know what's the primary key in the database? What is the primary key? You need a key, right? So no more than one record can have the same primary key, isn't it? If the primary key says user ID, then every record has to have a unique user ID, right? So here we have, say, a database of employees. Okay, so all the employee names and stuff like that are there. Probably here the username is a primary key, but here that is not a real issue. We'll come to that a little later. But what is the problem we are trying to see is what's called the inference problem. The inference problem is you try to launch some regular queries like SQL queries on the database, which as it is may not appear to reveal any sensitive information. But when you put together the results of one or more SQL queries, it will reveal some sensitive information, right? So the problem is, a single SQL query may not reveal any sensitive information, but when you put together the results that you get from two or more SQL queries, you will be able to infer. Infer means gather some sensitive information. So for example, if you are interested in finding the salary of this Laura Richards, that's a sensitive information, right? Finding someone's salary. So you cannot launch a query as it is by telling select salary from employee where name is Laura Richards. It's going to return an error message because the database can be programmed not to return the salaries as it is through a SQL query, right? So typically what we do is we use the statistical we call the statistical methods on the SQL queries to gather or to try to extract some sensitive information, right? So how can we do this? This is not revealing any sensitive information because it says select average salary from employee where sex is female. So all it tries to do is you are trying to find the average salary of all female employees, which by itself is not sensitive, right? It doesn't reveal the salary of any single female. It just tells you the average salary of all the female employees, right? So yes, no?
Oh, no.
But so you want to do this in two or more queries. The first query could be select name and state from employee where sex is female. So if you launch this query on the database, by the way, this slide is not there.
Yeah, I was looking for it.
Right, so I figured it out and I put it. Okay, so you may want to print it out. Okay. Alright. So select name and state from employee where sex is female. So if you launch this query on the database, it's going to return these three information. And this by itself is not any sensitive. All you're trying to see is who are the female employees working in that organization, right? The name and state. Now what can you infer from this thing? Laura Richards is from Michigan, right? Again, the goal is going to find her salary, okay? So she is from Michigan. So now what we can do? Pass another query that says select average salary from employee where sex is female and state is Michigan. Once you find out that she is the only employee from Michigan, use that information and say the sex is female and state is Michigan. So which means this query will process only on one record, right? Because it's only one record corresponding to a female employee with from state of Michigan. So even though you are calling it as average salary, it may look non-sensitive, right? Average information is not sensitive information. But since it's going to work on only one record, it's really returning you the salary of Laura Richards. Right? So using these two queries, you can really infer what is the salary of that employee, which is sensitive information that you can infer from queries which appear to be revealing non-sensitive information. Okay? So this is called the inference problem or inference attack on databases. Okay? You see what the problem is? You can launch some queries which appear to be very statistical in nature, which you think may not reveal any personal information, but when you put together the results, you will be able to infer or gather some sensitive information on a particular person.
So it's like you just ask for more general information to specify like.
Yeah, it appears to be more general information, right? You're calling average salary, name and state, all these are appearing to reveal only general information. But when you put together all those things, you can really infer what is the salary of a particular user. Okay, so you have to really study the database using some queries and then try to put together the information. So how to prevent this? So before that, let us see another scenario. We have kind of a student database where we have all student names. So from an exam point of view, again, I could give you a database like this and ask you to, since all of you have taken some database course or exposed to SQL queries, right? At least write in words what should be the queries that you will launch to gather the particular information. for example, the previous example, what will be the two SQL queries? These are the two SQL queries you will launch to find the salary of Laura Richards. Right? So that should be the kind of questions you can expect from this particular topic, at least the inference problem. And then we'll move on to the solutions. There we'll see the different ways you can prevent this. So now we have the student database where you have the names of all students, the sex, the race, the financial aid they are getting, the fines they are paying, whether they consume drugs or I don't know how many drugs they consume, and the dorms they stay. Okay. Now, I think the thing that we are trying to find out is whether a particular student is receiving any financial aid or not. So we could query the database to report the total of student aid by sex and dorm, which means I want to find out in every dorm what is the total financial aid received by all male students, what is the total financial aid received by all female students. Again, we are calling only for the total of the financial aid of all the students. We are not calling asking to find out the financial aid received by a particular student. So it is okay. It is not considered a sensitive query, right? But always total, average, and all those things are very general things. We are not really asking for any specific use of information. So it looks okay. But now you see here, there's a 0 over here. So what it means? No female student in the dorm gray is receiving financial aid. Right? That's what it means, right? If it is a 0, it means no female student in dorm gray is receiving any financial aid. So now go back and launch another query through which we can find out who are the female students residing in dorm gray. And if you happen to find out there's only one student, which will be probably female, gray, this, Liu. So Liu is the only female student in dorm gray. She's the only female student. The other students are male. This is a male, this is a male, this is also a male. So out of the 4 students in dorm gray, the only female student is Liu. Right? And you see the financial aid is 0, which means you can infer that Liu is not receiving any financial aid. So it is sensitive because the other students may be receiving financial aid, so they all look down on her and tell that you are not receiving any financial aid. Okay? So it may be sensitive. Okay? You get the idea? And also you can count, so this is probably another way. You can count the number of students by dorm and sex. So just add up the number of students in each dorm, male and female. So these are the number of students, male and female in each dorm. And again report the total by aid by sex and dorm, again which means there's only one female in that gray dorm and the financial aid is 0. On the other hand, you can also infer how much a person, so that this can be done using the previous approach too, right? But the new thing we can also do is, you see here, there's only one guy, male, in the Holmes dorm. And you see this is 5,000, which means you can again print all the male students in Holmes dorm, and if it appears to be only one male student coming out, then you can find out what is the aid being received by that particular student. So, any personal information, telling this is the aid that so and so is getting, or this is the salary of particular user, is going to be sensitive. So this will help you to find out the aid that's being received by a student in particular dorm. Similarly here, 0 and one more here, right? So you see how you can really launch queries which appear to be very generic, count, total, average, and all those things can reveal some sensitive information, right? Understood what's the problem? This is what's the inference problem, right? Using some very common statistical queries like this, and general queries revealing that appear to reveal only non-sensitive information. We put together the results of all these queries, we can infer some very sensitive information. Yes?
What if it's more than one person?
Huh?
What if it's more than one person? All these examples are one.
If more than one person, you try to go with the field. Remember the Michigan example? If there's more than one female, try to isolate as much as possible. You cannot, of course, succeed all the time. That's why you have to launch several queries until you can really narrow down to one record. Okay? Yes.
Like, they can, launch a query, like, they could use like the last name, or they could use last name start with R or something like that in the query, just keep narrowing it down till they get to that page.
If the administrator allows you to search based on names, that's what I'm going to say after this. To prevent this inference attack from administrator point of view, the DBA, the database administrator, can restrict the user from running certain queries. If you, as you said, you may be able to search by name, but that's more obvious, right? So if you want to find salary of, say, some user, I can say select salary from the employee database where name equals so and so. That's very sensitive information. So the DBA should have really restricted or kind of what I call blacklisted such queries. Should not be allowed to be executed. These queries appear to be very general. There's nothing sensitive in finding out this. Nothing sensitive in this. So these are the things that one can use to launch the attack.
So how do they block it? By like not allowing you to, like
You should ask your database inspector.
inquire about specific people?
Do a SQL project and see how can you block. I have not done it, but that's what DBAs should do. They can block searching based on certain columns, searching based on the names, like as I said. Okay.
When you have like a bunch of tables, so you have like thousands of tables or something, you have the system that manages your database, and you can tell it like if somebody queries this specific record and cascades down to another record, you can tell them to tell it to them.
So, okay.
You know what I'm saying? So like if you do like an indirect query to that record, you can tell what somebody searches and it so happens to match that record.
Okay, so you can set some settings in the database that, okay. I think you guys should do a project on MySQL or some database, right? Okay, one solution. We are going to discuss a couple of solutions, probably not everything today, but one solution is using what's called views. Have you used this views, SQL? Okay. You should have somewhere in the database course used it. Each user can create what's called a virtual table. So the employee table that we saw is an actual table, right? But the DBA can have each user not directly work on that table, the original tables. Each user can work only on what's called a virtual table. Okay? So which means a particular user, each user may have a virtual table. That's called a view. And that user can only access the virtual table. And if at all he makes any updates to the virtual table, the updates are reflected on the original table. So what